The human body is an incredibly graceful machine, able to produce a wide variety of movements, and nowhere is this more obvious to me than in the human arm, able to move up and down and forward and back and rotate around and put itself into just about any position. The reason it's able to do this is thanks to the unique shapes present on the arm bones. The humerus is the single large bone in your upper arm, and it articulates with the pectoral girdle at a shallow depression in the scapula called the glenoid fossa. The radius and the ulna articulate with the humerus at its distal end, and they run somewhat parallel to each other, so you have one bone in your upper arm and two in your forearm. In our ballet dancer's right arm, the radius and ulna are parallel to each other, but in her left arm, the radius pivots and twists around the ulna, allowing her to rotate her palm forward. In order to allow this motion, each of these bones has to articulate with each other in a very precise way. So what we're going to do now is take a look at some of the surface features of the humerus, and then in the next video, I'll take a look at the radius and the ulna. The humerus is probably the most classic-looking long bone in your body. If you ask a child to draw a bone, they'll draw something that looks approximately like the humerus. There will be a long cylindrical shaft in the center and two lumpy ends. The shaft is also called the diaphysis, and the two ends are known as the epiphyses. Quick note on the spelling of the word humerus. I have a bad habit of writing humerus as in funny, but there is no O in the name of this bone, so watch out for that. Don't repeat my mistakes. There are three notable lumps at the proximal epiphysis. The largest of them is called the head of the humerus, and that's what articulates with the glenoid fossa of the pectoral girdle. But there are two others which we call tubercles. Tubercles is a general name for a bump that you find on a bone. Laterally, we have the greater tubercle, which serves as a muscle attachment site for some of the rotator cuff muscles, supraspinatus and infraspinatus. The lesser tubercle is smaller and it is located medial and anterior to the greater tubercle, and this serves as a muscle attachment site for the subscapularis rotator cuff muscle. In between our tubercles, you find a groove or sulcus, which is, logically enough, called the intertubicular sulcus. It's also called the bicipital groove because this is where the tendons for your bicep actually attach in. The tendons for your pectoralis major muscles actually cover the tendons for your bicep and attach laterally to this groove, and the tendons for your teres major muscle attach medially to the groove. Next up, the humerus actually has two necks. The anatomical neck is exactly where you'd expect it to be, just beneath the head, but the surgical neck is this kind of thinner portion of the bone just below the anatomical neck. This is an area of the bone that gets fractured frequently, so surgeons started referring to it as the neck, so this is kind of a practical distinction more than an anatomical one. The bump on the lateral side of the humerus, about a third of the way down the shaft, is called the deltoid tuberosity. As you might expect, this is where the triangular deltoid muscle connects. Now let's take a look at some of the features found on the distal epiphysis. This is where the humerus articulates with both the radius and the ulna. Since we're looking at this humerus in an anterior view, we can see a small rounded projection referred to as the capitulum. The head of the radius has a cup-shaped depression which perfectly fits around this capitulum. Medial to the capitulum is a kind of cylindrical-shaped portion of the bone, which is referred to as the trochlea. The trochlea articulates with the ulna, creating a hinge joint which allows you to flex your arm. Just superior to the capitulum and the trochlea are two shallow depressions, which we call fossa. The purpose of these two fossa is to make sure that when you bend your arm, your radius and your ulna don't catch on your humerus, so it allows you a little bit more of range of motion by creating a pocket for those bones. The depression above the capitulum is called the radial fossa, and the depression above the trochlea is called the coronoid fossa. One more lump to round off our discussion of the anterior view of the humerus. We have a bump that tucks behind the trochlea, which is called the medial epicondyle. That was a lot of bone features all at once, so let's review before we move forward. The large rounded prominence which fits into the shoulder socket is the head of the humerus. It is joined by two tubercles, the greater and lesser tubercles. In between them is the intertubercular sulcus. The shaft of the bone is the diaphysis. A third of the way down the diaphysis, you have the deltoid tuberosity, and at the end, you have the distal epiphysis. This features the capitulum and the trochlea, which articulate with the radius and the ulna, respectively. Now let's switch to a posterior view in order to get just a couple more features. So this is still a right humerus, but we flipped it around backwards, so now the head's on the opposite side. And down at the distal epiphysis, you can see the trochlea, that kind of cylinder-shaped portion. Again, we have the medial epicondyle, but in the posterior view you can also see the lateral epicondyle, which is kind of hidden by the capitulum in the other view. The last feature I want to show you is the Olecranon Fossa, which is just above the trochlea on the posterior view, and this is where the tip of your elbow kind of tucks when you have your arm fully extended. In the next video, I'll discuss the bony markings of the radius and ulna as well, and hopefully we'll see how they all fit together.